we've already talked about factoring before. The kind of factoring is this that's in the warm-up. A couple things throughout the notes today we've actually talked about. There are two different kinds of factoring that we have not talked about that we will today, which is the sum and difference of cubes, and then also factoring by grouping, which we'll get to that. Okay, so this in the warm-up, you should be able to do this. If you don't know how to do this, you need to be coming in. I should be able to give you a quiz over this right here, and you should know what to do. Alright, so looking at number 1, if I multiply my A and my C term, 1 times 12 is 12. What factors of 12 add up to 4? Or sorry, add up to 7? 3 and 4. On this problem, do I have to write my answer as x equals? Yes or no?
Yes.
Why do I not have to, Meredith? Or was that just a lucky guess? It is in factored form, but why do I not need to solve it? What do the instructions say to solve? Or does it, okay, if it just says to factor, that's all I got to do and I'm done. Alright, so looking at number 2. Again, A times my C is negative 10. What factors of negative 10 add up to positive 3? 5 and negative 2. Okay, and then I'm done. Let's jump down. Let's do 4 first. Before 3, it's a little bit simpler. So what do I need to do first on number 4 that I did not have to do on number 1 and 2? Do what, David? Greatest common factor. What is the greatest common factor? 3. So I'm going to divide every term by 3. And then now, I'll do the triangle. 1 times negative 7 is negative 7. What factors of negative 7 add up to positive 6? Positive 7 and negative 1. Whenever I write this, if I factor this, do I have to include that 3 right there? Yes. Okay, because if you're listing out the factors in factored form, which that's exactly what it is, you can't multiply those 3. Sorry. You have to have that 3 whenever you multiply those to get to what the original answer said. Original problem said. Alright, going over to 3. Jacob, what do I need to do first?
What I did was I did greatest common factor.
Which is what on this one?
4.
Okay. So greatest common factor of 4 is going to leave me with this. Go ahead and do that. So now 2 times negative 3 is negative 6. What factors of negative 6 add up to negative 5?
Negative 6 and positive 1.
Negative 6, positive 1. Am I done with this problem? Am I done factoring this? No. Which is probably why I'm asking that. What else do I need to do? That's what I'm putting up there in the red boxes. What is different about number 4 or number 3 compared to the others? There's a 2 in front. Okay, remember whenever there's a leading coefficient other than 1, okay, it's not here because I factored out the 3. Here I factored out the 4, but the 2 is still there. So what is it? If anybody can remember, what is it that I have to do with that 2? Do what, Meredith? No. Alvin? Divide what?
Your -6.
I'm going to try to divide the 6 and the 1 by whatever that leading coefficient is. 6 divided by 2, does that divide evenly? Yes. So I divide it and I leave it as 3. Does 1 divided by 2, does that divide evenly? No. So where do I put that 2? In front of the x. And now it is completely factored.
So if there's any coefficient in front of.
Alright, let's go to the next part. So this next part is just about greatest common factors. Alright, so looking at 3, what would the greatest, 5, what would the greatest common factor on 5 be?
3.
Do what? 3x. Because that last term has an x on it. So that's going to leave me with x squared plus 4x minus 12. And then you just factor it like normal. So I've got the factors of -12 that add up to 4. Which, what would that be? X plus 6 and what?
X minus 2.
X minus 2. Okay. Looking at number 6, Jeremiah, what would the greatest common factor be?
6.
What else?
6x.
6x. And I'm left with what in there? X what?
X and 6.
Positive or -6? Negative. Thanks, Alvin. Okay. Am I done factoring this? Okay. And this is always okay. And this is always kind of a hard part of factoring is because there's so many different ways to factor, and so a lot of people struggle with when am I actually done factoring? And I've briefly mentioned it. It's been a while. Does anybody remember how you can look at something and say, I'm definitely done factoring that? When there's no exponents. Okay, you look at the 2 answers that we got on those 2. You look at the answers we got in the warm-up. All of our answers had no exponents. Okay, so whenever you have no exponents, you're definitely done factoring. Now we're going to run into a situation later on in the notes that we'll need to talk about concerning that. But no exponents, you're definitely done. Go ahead and do number 7 for me. Okay, on to this next part. So this is a new way of factoring that we hadn't talked about yet, called factored by grouping. Looking at these 3 problems, what do you notice about them that's different than kind of what we've seen so far? There's 4 terms, which is a big indicator that you could use this method. And a lot of times a lot of times the degree of the polynomial is probably going to be 3. Okay, now you can do it with other degree of polynomials, like number 9 is 2, and we'll talk about that one. But to do factor by grouping, the first thing you're going to do is you're going to group the first 2 terms together, and you're going to group the second 2 terms together, hence the name factor by grouping. Within each group, you're then going to look for the greatest common factor and pull it out. So on that first group, what's the greatest common factor?
X squared.
X squared. And I'm going to be left with x minus 3. Alright. Now, if you notice, on the second group, you've got negative x. You do not want to have that x does not need to be negative. Okay, so if it's ever negative, at the very least, you're going to pull out a negative 1. Alright, which is this situation, because there's nothing else we can pull out of there. And so if I pull out that negative 1, what does that 3 become? It becomes negative 3. Now, what do you notice? What sticks out about that right there?
There's a negative 1 between
No. Maybe that stuck out to you, but not what I'm looking for.
So that's the end.
That's not the answer. But what sticks out about that?
There's an exponent.
Nope. There's what? Nope. I have the exact same things in the two sets of parentheses. X minus 3 and x minus 3. If you're going to do factor by grouping, those two at this point in the process have to be the same. Okay, and if you know that rule, a lot of times that will help you determine what that greatest common factor is. Okay, for example, after I did the first one, it's x minus 3, I can look at the second group and say, what do I need to pull out to make it x minus 3? So a lot of times that'll help you in that process. The next step is you're going to rearrange what you have. The two factors that you pulled out, you're going to make those one of the factors. We pulled out an x squared and we pulled out a negative 1. And then the factor that's repeating itself. There's that. Now, am I done factoring this? No, why not? Because I've got an x squared right there, right? So I've got x squared minus 1. And we've talked about these before. If both of those are perfect squares, so this is an example of a difference of squares, how can I factor that? We've talked about a shortcut on how you could factor that. Alvin?
A minus b, a plus b.
Okay. How do I get the a and the b? Awesome. So whenever you have that, if both of those are perfect squared, x squared is a perfect square, 1 is a perfect square. I can take the square root, and we're going to do more examples of this here in a minute. The square root of x squared is what? X. The square root of 1 is what? 1. So that means I have an x plus 1, and I have an x minus 1. Am I done factoring that one? Yes.
So where did the x plus 1 and the x minus 1?
That came from that. Alright, so looking at number 9. Now, number 9 is quadratic. You've got x squared. And honestly, what I would do is I would combine your middle two terms to get negative 2x, and then I would just factor it the way we normally do with whenever I do the triangle thing. Okay? But to get another, we only got 3 problems under this section, so we're going to go ahead and do grouping. So let's walk through this one more time. So in that first set, what is my greatest common factor? 3x. Pull that out. I end up with x minus 2. So again, that helps me knowing what that is, because now I know my second set has to be x minus 2. And what is the common factor in the second set? 4. And so there's my two factors. 3x minus 4, and x minus 2. Okay, so you get to this point. How many of you got to this point and wasn't for sure what to do? Okay. So you got the x squared minus 3. So you have to look at that part, x squared plus 3. You have to look at that part to see if you can factor that anymore. Alright, this certain one you cannot. Okay, you can't factor that anymore. So going back to kind of what I said, you want to go until you don't have any, whenever you get to the point where you don't have any exponents, that means you are definitely done factoring. But there are problems where you can still have an exponent, but you can't factor that. Okay? And think about what we're doing whenever you factor or use the quadratic formula. Okay? You're finding, and we haven't looked at graphs in a while, but we're talking about quadratics, so parabolas. And those solutions are talking about whenever the parabola does what? Crosses the x-axis. Okay, so now think about transformations. If I just give you y equals x squared plus 3, that plus 3 is going to move the parabola which direction? Which one? Nope. It's not. It's going to go up. Okay, so it'd be there. As opposed to the x squared minus 1 that we did up top, that minus 1 would move the parabola which direction? Down. So I can factor that and get to real solutions. I cannot factor x squared plus 3 because it does not cross the x-axis. Alright, if you really, really, really want to factor it, that's going to involve doing the quadratic formula with x squared plus 3 and getting imaginary numbers. And I'm done with imaginary numbers. I don't know about y'all, but okay. So that's as far as you can go on this problem. Okay, sometimes that's just how it works out.
So why could we go further with 8?
With x squared minus 1? Because you can factor it. It's got real solutions. X squared plus 3 does not have real solutions. Going to 11. So this is the difference of squares. That's exactly what I was just talking about. It has to be minus for you to do this. And it's this process that Alvin already said. On 11, what is the square root of x squared? X. What's the square root of 81?
9.
So what are my two factors? X plus 9 and x minus 9. Now, the first term does not have to be just x squared. If it has a coefficient, that coefficient has to be a perfect square as well, though. So on 12, what is the square root of 9x squared? 3x. What's the square root of 64? So what's my two answers? 3x plus 8, 3x minus 8. Doesn't matter which one's first, the plus or the minus. Just need to have one of each. Okay, so that's pretty simple. We've talked about that before. And so here's just a few more examples of that. The next, that kind of leads into this next section. This is the sum and difference of cubes. If you understand, and hopefully you do because we've talked about it multiple times in here, what a perfect square is, it's not that hard to grasp the concept of what a perfect cube is. Alright, 2 times 2 is 4, so 4 is a perfect square. 2 times 2 times 2 is 8. 8's a perfect cube. 3 times 3 times 3 is 27. That's a perfect cube. 64 is a perfect cube. 125 is a perfect cube. Okay? It's just kind of to the next level whenever you're dealing with perfect cubes. This can be the sum or the difference. It does not have to be just subtraction like the perfect squares above. Okay? So you've got two different things you got to be aware of. One are the signs you're going to give in your answer. And you can use the SOAP acronym to get that. Okay, because all that means is if in the problem that you're given, if it is subtraction, the answers that need to be in the signs that need to be in your answer are going to be the same, opposite, always positive. If it's addition, same, opposite, always positive. And then whenever we kind of work through the examples, you'll see that's the first thing that I put in, are the signs. Okay? After that, to get the A value, you're going to have to cube root the first term. To get the B value, you're going to have to cube root the second term. Very similar to the perfect squares. It's just now you're cube rooting it instead of square rooting it. To cube root in the calculator, that is going to be math 4. Okay, if you have to do that. Once you have the A and the B, then you just fill in this pattern. AB, A squared, AB, B squared. Okay, so let's go to this first one. It is subtraction. So again, the first thing I'm going to do is I'm going to go through and I'm going to put my signs in. So I've got same, opposite, always positive. After that, my A value on this one is going to be what? X. What is my B value? And then I'll just fill it in according to that pattern. I've got A, B, then I have A squared, and give myself room on this one, AB, B squared. On the sum and difference of cubes, that's all you got to do. You're done. You can't factor, you won't be able to factor this one. And that's it. Alright, go ahead and attempt number 2, because I definitely want to go through 14, because I definitely want to go through number 15 with you. 15 is kind of an oddball.
15 would 8 or 2x.
Yes. Yes. Okay, so on 14, that is what you should have gotten. And let's go to 15. Okay, and again, 15 is kind of odd. It's got y in there. You won't see that a lot, but there's another part of this problem that you need to be aware of. So, first thing I'm going to do is go through. It's positive, so I'm going to go same, opposite, always positive. On this problem, what is my A value going to be? 2x. The cube root of 8 is 2. The cube root of x cubed is x. What is the cube root of b, or of 27y cubed going to be? 3y. 3y. Alright, so I'm going to go through and I'm just going to follow the pattern. Now, the first part, the binomial, that's easy because it's just A, it's just B. The first term of the trinomial, right here. What is that going to be on this one? Not 2x squared. Nope. Okay, and this is the part that I was saying you need to be aware of. If you're squaring all of A, okay, look up at there at the very top. It is not this, it's this. So what does that become? What is 2 squared? 4. So 4x squared. Okay, my middle terms ends up being 6x, y. You just list the variables. And so if this is 4x squared, what's this last term going to be? 9y squared.